Hi guys, welcome back. I'm Farhana. This is our third lesson on trigonometry rules. Today we're going to be doing the cosine rule. Okay, let's get to it. So, have you ever thought about how it is possible to solve a triangle when you don't have one full pair of sides and angles? So, remember when we did sine rule? We needed one full pair of sides and angles. Today, we're going to be doing the cosine rule. Let's look at our concept map quickly. So, we've already done the sine rule, and today, we're going to be doing the cosine rule. Okay, let's look at this triangle that they've given us here. We have a triangle ABC. Let's look at what information is available on this triangle. We've been given side AB with a length of 13 units. We've been given an angle A that has that is 70 degrees, and we have side AC that's 4 units. Now, is it possible to use the sine rule here? Remember again, for the sine rule, what do we need? We need one full pair of angles and sides. So, we need an angle and its matching side. We have this angle, but we do not have the matching side. We have these sides, but we do not have the matching angles. So, in other words, in this case, we cannot use the sine rule. So, because we can't use the sine rule, we need to find another rule, or we need to have another rule in our toolbox to solve non-right angle triangles. So, let's go and look at what the cos rule says. The cosine rule for any triangle ABC is pretty simple even to memorize. It states that for any triangle ABC, A squared equals to B squared plus C squared minus 2BC cos A. This is pretty simple to memorize because if you look at the statement, it begins with the letter A, which represents the side A, so that one, and it ends with the angle A, which means the angle directly across it. So, the angle directly across from A. So, A squared equals, and here we start adding the other two sides, B squared plus 2BC minus, B squared plus C squared minus 2BC cos A. Can you perhaps guess what the next version of it will be? Let's see. B squared will equal to, now what do we fill in here? Obviously, we need to fill in the other two sides. So, it will be A squared plus C squared minus 2 AC cos B. Okay, and the third version, can you guess it now? Because we're starting with C squared, we now still need to use the other two sides. The other two sides are A squared plus B squared minus 2AB times cos of the angle we started with. And since we started off with C, we need to end off with C. Okay, now what does this mean? Let's look at the first example. So, A squared is equal to B squared plus C squared minus 2BC cos A. What do we need to be given in order to use this formula? First of all, we need to be given B squared. So, we need to be given B squared. We need to be given C squared. So, we need to be given that length. And we need to be given this angle here. So, this angle here. So, if you look carefully, we're looking for information in a V pattern. So, our V pattern looks like this. Because we're finding angle A, side A here, we need to be given B, C, and the angle in between, which is angle A. Okay, and similarly for b squared. If we need to find b squared equals to a squared plus c squared minus 2ac cos b, then we're looking for this one here, we're looking for b, okay, but we need to be given a and c. So we need to be given little a, little c, and we need to be given angle p. So again, we need a side, an included angle, and a side. Similarly here, we needed, in the previous example, we had this side, this angle, and this side. So let's see what we can conclude. We use the sine rule when we have two sides and an included angle. And here's our three versions that we had earlier. Okay, so let's look at this triangle, and what would be the three versions of the cos rule for this triangle? Easy, let's go. P squared will equal to q squared plus r squared minus 2qr cos of p. We began with p, little p, and we ended up with the angle p. The next version will be q squared. So now we're going to start off with the other two sides squared. So p squared plus r squared minus 2pr cos q. And the last one, r squared. So r squared will equal to p squared plus q squared minus 2pq times cos of the angle we began with. We began with r, so we have to end our statement with r. Okay. Right, so how do we write the cos rule for this triangle if we want to find p squared? Then obviously we're going to use this version of it. P squared is equal to q squared plus r squared minus 2qr cos of p. So what three things do we need? Because you need three things to solve this. So basically you need to be given side, sorry, that's an error. Let me just erase that quickly. We need to be given q, r, and the angle in between. So we're looking at side, angle, side, like this. Those are the three things we need to be given. We need to be given q, r, and angle p. Okay, last one. Let's try this one. If we want to use cos rule in this triangle, and the triangle is KLM, what do we need? K squared will equal to L squared plus M squared minus 2LM. And because we started off with K, we have to end with the angle K. So what three things do we need? We need L, we need M, and we need to be given angle K. Let's quickly look at how these three things lie. L, M, and angle K. Okay, so now we at least have an idea of how we apply the cos rule in a triangle. After the break, we'll do some examples where we actually solve triangles. See you then.